Welcome to the third day of our Fme UN migration training. Today we will be stepping through the simple migration. So this is more of a deeper dive into the migration template workspaces that you will be working with. The simple migration is more of a schema mapping exercise that we will walk through in quite some detail. And then we will also cover some troubleshooting steps as well in areas that are probably going to require some modification depending on your data set that you will be working with. To get started, you can find the workspaces that we will be using located in the Fme data Esri UN simple folder. I'll chat out that path here. Send out the path in the chat window to everyone. So we will be working out of this folder for the majority of today. And in it for today, the first step we're going to be working through is the schema mapping exercise folder. And we're going to be opening the water schema mapper complete worksheet. I'll send out the path for that as well. Now this is an Excel worksheet. While we don't have Excel installed on the machines, we do have OpenOffice. So if you double click on that Excel sheet, it should open in OpenOffice. You may be required to enter your username, but once you put your name in, it should just open up like you see on my screen now. Now for this worksheet, you'll notice there's a number of different tabs down here located at the bottom. Now we'll step through the majority of them one at a time, and some of them are fairly repetitive, just broken down to better ease the sanity check, so to speak, of not becoming monotonous. So the first sheet that we're looking at here is the asset types. Now this will be where the bulk of the changes will be made, and this is where it will change from a user-to-user data set the most, because this is where you are going to be creating the mappings that are going to create the asset groups and asset types, which are mandatory when uploading into the utility network. Now the way that this Excel sheet will work in Fme is that for some of these fields, we require a filter basically. And the way that it works is we'll set one field as the attribute name and a second field as the attribute value. So a case in point would be here, this primary attribute name column. So in this column, this is just going to be the attribute name that we're looking for, whereas the primary attribute value column will be the value that we're looking for that attribute. So if we were looking for a material attribute with a value of DIP, this is where we would be setting that. Now we'll just step through each of the columns just to make it clear what they are. We have added some comments. I'm not quite sure if we can view comments in yeah, you can view them in OpenOffice. So we have added some comments to ensure, to try to be as transparent and provide as much information as possible to help you succeed. So the first column we have here is the UN feature class. This is basically the feature class that you will be writing to for the asset package. So that could be water line, the water device in this case, with the fact that we're looking at water. It could be structure, line, and so forth. The asset group value and the asset type value, these are the actual coded value that will be written to the asset package and then be utilized when you upload into the utility network. Now the asset group description and asset type description, these are more for sanity checks, so to speak, and to provide you with provide you with more substantial information about the feature that you are working with, because it can be difficult to just work with the code, so you don't exactly know what the feature that you are modeling or dealing with at the time specifically is. Now, it is important to note that these are only used primarily, like I said, as the sanity check, but they are also used in the association table, the descriptions rather than the codes or the values. The ArcGIS feature class here, this is your source feature class. So this is where you will be modeling from. So this is where you will start to change the spreadsheets to model your data set. The primary attribute name, primary attribute value, and so forth for the secondary and tertiary. These are where you start to set your filters. So this is where I talked about earlier, where you want to differentiate features between each other, using these first two fields as an example. So if I have two water main features, one water main feature that I want to map to a distribution main. If I have multiple materials based on the asset type, so it could be copper, it could be ductile iron, could be an unknown if I don't know the material type, I still need to map each of my sources to the correct asset so they have the correct asset type. So this is where these filters come into play. So taking a look at these first ones here, so I see if I have a water laterals with a material of COP or copper and a line type of hydrant, I'm going to be modeling that to a hydrant service asset group with a copper asset type. And conversely, if I had a ductile iron pipe with a hydrant line type, it would be going to hydrant service and ductile iron. So that pattern repeats throughout to cover your source data. Now, it is important to note, while we only have it set up for 3 filters here, you could set up as many as you wanted. It would require a little bit of additional customization in the workspace, but it is possible you could add as many of these filter types as you would like. It's just important to note again that you will require the attribute name column and then the attribute value you will be looking for. Now you'll notice a couple of fields over here. Now what these fields are used as, these are used as the attribute names. Now they correspond, so the asset type, the asset group, and then the type description and the group description. These will become the new attribute value or attribute name for the asset group and the asset type along with their descriptions. So for example, if I was to change this field to, let's go asset name. So this means that the asset type value would now be within the asset name. So that would be, so the asset type here would be in the asset name. So it'd be asset name equals 88. So for the most part, you will just want to, these would just be copy and pasted all the way down to cover each of your mappings. Now this middle column here, this feature type attribute, this one's a little different. This is this is a Fme format attribute, and basically it is the feature type name of the source. So this is where the this is the primary factor of the filtering in regards to, so if the Fme feature type, which we'll cover a little bit later as well, is, scrolling back over, is water mains, then it would look for this filter. So the Fme feature type always needs to correspond with the ArcGIS feature class. So it's basically your source. Now it is important to note that Fme is case sensitive, as we mentioned yesterday. You'll notice that all of my primary attribute names are uppercase. Now, the reason for this is we force within the workspace everything uppercase. That way, it becomes a uniform workspace no matter the data set you're working with. So if you had all yours in lowercase, it will convert to uppercase, and then we give you an option to write out to your desired case. So that is something, that is one of the big trip ups, is the case sensitivity. Now you will notice another thing here, this little null here. Now Excel doesn't recognize a true null, whereas your source Geodatabase, for example, will recognize a true null. So through a little bit of trickery in the workspace, we have to create a dummy mapping, so to speak. Now we do this through this little concept of this null with the brackets on it. Now this will basically allows us to create this dummy mapping, so it will treat this like a true null, and we will step through that a little more in detail a little bit later when we're looking at the actual workspace. So that's it for the asset types sheet. Now we'll take a look at the domains. Now the domains, this is where you want to map any of your existing domains to a new domain, or just a regular value field to a new domain. So we'll just step through the column names here just so we're clear with everything. So the Arcgis feature class is the source feature class that you may need to filter on. This isn't mandatory. So for example, you'll see here, I have material. So if material was uniform across your entire data set, you would not require this Arcgis feature class to be populated. Now the Arcgis attribute name and the UN attribute name, these are the names of the fields that you are populating and from the existing. So the Arcgis attribute name is your existing attribute name, and the UN attribute name is your target name that you'd like to write to. Arcgis description and UN description, these are not used at all. These are merely just for a sanity check, just to provide you with more information as to what the actual code represents. I know when I was working on these spreadsheets, I found it very difficult without the description because you just start to see codes everywhere. Now the codes and the UN code, the Arcgis code and the UN code, these are the primary values that you will be mapping from one to another. So in this case, let's see if I have one here that does not match up. Here, so abandoned, I'm writing it to so from the source was abandoned, the code, I'm now writing it to an integer code, so it's going to be a 4. And so again, these the Arcgis code and the UN code, these are the mapping from on the Arcgis code to the 2 for the UN code. Now the feature type attribute, this is the similar to how I described in the asset types. This is the source feature type or feature class that you are mapping from. As I said earlier, this is not required for all features. If you were doing subtype, if you have an existing subtype in your source and you wanted to map that to a domain, that you could do that through setting these Arcgis feature class and the feature type attribute. Again, this feature type attribute will always be this FME underscore feature underscore type attribute. It will always be this. And then the secondary attribute and secondary attribute value. These are if you just have an additional filter that you would like to provide, similar to how I described in the asset types. So yeah, so this is where you would set your secondary filter with the name and the value. Had a question. So yeah, kind of to reiterate, yeah, we tried to color coord. So yellow would represent your target or the asset package that you're writing to, while these orange or like brownish tan colors would be your current, your source data. So stepping through to the waterline. So the waterline, device, junction, assembly, and the structures, these kind of follow this very same layout in regards to, this is where we're doing the attribute name mapping. So this is where you would be changing, basically name changing any attributes that you would like to. because remember, this is a consolidation of feature classes. So you may have had 15 or more feature classes in your source geodatabase. You will be condensing those down to 7 for your specific domain. So for the attribute mapping layout, it's laid out with the UN attribute name, the Arcgis feature name, and then a default value. The UN attribute name is the name that you will be writing to in the asset package. Now this spreadsheet is set up with the default asset package. So if you had made any changes to the asset package, whether it's adding attributes or anything like that, or you would need to add those to these spreadsheets. The Arcgis feature attribute, this is the attribute that you were mapping from. Now you'll notice I have a lot of blanks. Now what this means is that this isn't mandatory. So there's certain fields in the asset package that I might not have had modeled at all in my source. So you can leave those blank. Now if you'll see here global ID will be written as global ID lowercase. See another one, install date will be written as install date. Let's see if I have it here, diameter in my source will be going to nominal diameter in my target or my asset package. Now you'll notice a couple here with domain mapping. Now these are basically just creating a dummy feature to allow you to understand where they're coming from, but it will not actually do the mapping here. Now the reason being is for material here, it's the same as the UN attribute. So you're just able to do that in the domain mapping here. So you could change this. You could change this name here to match your target. And then lastly, this UN attribute default value. Now what this is used only if a feature, when the feature does a mapping, if the value is not populated, or if the attribute never exists to begin with. So for example, you'll notice I have nothing here being mapped to creator. So this means that creator doesn't exist. This means that when creator, so if I said, let's go, just do creator with an ER. So if I were to do this mapping, if I had a specific feature that did not have this creator feature populated, it would map it to a default value of migration. So you can populate this, or you could leave it blank if you'd like. This is optional, as you can see the comment here. It's optional. It's entirely up to you on whether or not you use this field. It can be a little confusing. Now this process repeats for each of the feature classes that you will be mapping. So you should have one for each of the 7 feature classes in the asset package. So that's the 4 for your domain specific one. So that's water, gas, and then 3 for the structures, the structure junction boundaries and the structure lines. Now we do have another sheet over here, and this is called the terminal configuration assignment. Now this is basically just used as a lookup. So you don't really need to worry about this. I don't think you would be adding anything to this table. If you were to add any terminal configurations, which is in the asset package, you would then add those additions here, but they would have to also exist in the asset package as well. So that's it for the spreadsheet. So now we'll take a look at the Schema Mapper transformer. I know we covered it yesterday, but we're going to step a little more in detail for it. So this one, we're going to go to Schema Mapping Setup. and the begin. I'll send out the path for everyone. There's the path to the first workspace. And remember, you want to right click it and open, ensure you're getting the 64-bit workbench. The reason being is because we're reading from a geodatabase, we need a licensed version of ArcGIS, and we licensed ArcGIS Pro, which is also 64-bit. Zoom in here a bit. So what we have here is just a very simple workspace that will actually kind of follow the majority of the schema mapping that we will be conducting in the larger scale water workspace. So we're going to step through the first, you may get a warning. The reason being is because these workspaces were created with an older version of FME. They were created with just a slightly older build. Whereas we have the latest version on these virtual machines. So you will get a warning, but you should be able to safely ignore that warning for the time being. So just taking a look at this quick workspace. So we have a source feature class, which is called water fittings. We have a bulk attribute renamer. A null attribute mapper, an attribute creator, and then a little bit of a blank, and then a couple more transformers. So we'll start at the beginning. So here we have our source feature class. In this case, it's coming from a file geodatabase, and it's the water fittings feature class. So I can take a look. I can see it's a point geometry. I can see the attributes that I have on it, and the format attributes I have on it. Now, for the most part, you can safely ignore these format attributes. However, this FME feature type is required on all the source feature classes, because this derives the schema mapping. So you would want to ensure this is exposed. So just a little check mark. Next, we'll look at the bulk attribute renamer. Now, this is where I mentioned earlier, this is where we force everything uppercase. Now, this is, again, just to ensure uniformity along with any of the source data sets, because you could be dealing with camel case, you could be dealing with lowercase. We just want to ensure that the workspace requires as little modification for you as possible. So we just force everything uppercase. Now, the null attribute mapper. Now, this is where this is where the idea of that dummy null value comes into play. Now, what this is doing is basically, so first, we're going to select our attributes. So in this case, we have global ID and fitting type. Now, the map to section is where it's important. So for the most part, it's if the attribute value is a null or empty. Now, this null here is a true null. We want to map it to a new value. In this case, this dummy value. So this null here, this value here needs to match the value in your spreadsheet. This one here. So that value needs to match this value right here. If they differ, including case, it will not be picked up when your features go through this schema mapping here. So any null value that you will be making use of in the spreadsheet for the schema mapping, make sure that you have that attribute selected. If you don't have any attributes that are nulls that you need to do mapping, you could just select it as your global ID or your object ID field. Because those should always be populated, so it just would not, it would remove the error that you would get otherwise. Because if I remove this, say I don't have any values, and I would try to run this, it will error out saying, hey, you have, or it won't error out, it will provide a warning saying, hey, you have transformers with incomplete parameters. Like here, this is the warning you would get. So I could run it without it and just see what happens, or I could just cancel that and just select a field that I know will always be populated, such as your global ID. Now I will go back and have both selected just to be safe, the fitting type and the global ID, and click OK. Now this attribute creator, this is where we basically just set a value for a new attribute. We call the UN feature class, and this is basically just it's used for lookups at certain times, depending on if you have a feature that might have the same mapping for two different targets. So taking a look at the spreadsheet. So if I had a fitting that would also be potentially mapped to, say, a fire hydrant, if the filters were the exact same, then we would make use of that UN feature class, which should align with this feature. And it basically just provides us with a higher level of doing that comparison and that join, so to speak. Now this is where we'll add a schema mapper. So if you select this attribute creator 13 and then start typing schema mapper, you should have a little dialog box that pops up with the transformers, and you'll want the schema mapper. So you can either just click it or hit enter, and that will connect it to the transformer that you just had selected. Now here's where we're going to set it up. So if we just open up that schema mapper, so first we want the format. So because we're dealing with an Excel file, that's the format we're going to use. So the format will be Excel, so you can just start typing Excel and then hit enter. And then we're going to click the little ellipse here for the data set. And you'll want to navigate back to the simple, to the schema mapping setup. And then you want this water schema mapper dash complete. Now we can go to parameters. Now, because the first step of this schema mapping that we're going to be doing is we're going to be doing the asset group and asset type assignment mapping. So we really only care for the most part about this asset types. Now you could read every single sheet in here, but that is a performance hit. So in this case, we want to deselect all of them and then reselect the top one. So this will allow it, so we're only reading in that one sheet. And then if I select on this sheet here, I can see what the layout of it is. So if I can just, I just widen this here, I can see basically a preview of what that sheet will look like. And then along with the fields that are being recognized as the attribute fields. So we can go ahead and click OK. Now, one thing I should note, just for complete transparency, is the spreadsheet we're using, which is the one I showed here. While it looks like there's only a couple values here, this actually is the entire sheet. You'll notice here on the numbering that the numbers jump around quite a bit. And the reason for that is because I have most of the fields hidden. You could go through this and unhide those fields or unhide those cells so you could see the complete asset package model. For the most part, a lot of them are blanks because the source data set might not support that. But just to be completely transparent of why you could see discrepancies between the preview in the Schema Mapper preview here, and the Excel sheet that we were just looking at. So we'll go ahead and click OK. And now next. Now this is where we actually set up the Schema Mapper. Now this is where we'll set the filters as well as how the new feature is created. So first we'll go to hit this little plus sign down here and we'll go to filter. Now, this is where that idea of you need the two fields in your spreadsheet, one with the name and one with the value. So for this case, we're going to do the Fme feature type first. So the attribute name that we're going to do first will be the Fme feature type, which is feature type attribute right here. So that will be our name field. And then our value will be ArcGIS feature class. And you can see here in this little schema mapping table preview, it will highlight the fields that you are using. So in this case, our feature type attribute here is the ArcGIS name field. And then the ArcGIS feature class is the value field. So that's one filter done. Just going to share that Excel sheet path to everyone in the chat. So just to review, cancel that. So Schema Mapper. So you select your format. You then select your spreadsheet. You would then go to your parameters. And select the sheet that you want. For the most part, you will only want to read the specific sheet that you are using. So in this case, we only want the asset types. We would then click OK. And then we hit next. Now this is where we actually set up the Schema Mapper. The first part is just setting up how the Schema Mapper is going to interpret that schema or that spreadsheet that we will be utilizing. So to set up a new filter, again, so we understand completely these steps. So it'd be insert row here. Select the action you want. In this case, we want another filter. And then for this one, we're going to do the primary attribute name and the primary attribute value. So the attribute name would be the primary attribute name, and the attribute value would be the primary attribute value. So in this case, if basically what this would say is, if material would be here as the name, and then a DIP would be here as the value. And we'll do one more. We require one more for these spreadsheets for the example. So again, it'll be insert row, filter, and so we've done the ArcGIS feature class one we just did the primary attribute name and value. We will now do the secondary attribute name and secondary attribute value. So the attribute name would be secondary attribute name, and the attribute value would be the secondary attribute value. And click OK. Now for the primary attribute names and the secondary attribute name and value, these filters, you could add as many as you wanted, depending on how many filters you require. So if you had, a fourth attribute name and value, a fifth, a sixth, and so forth, you could continue to add those to the Schema Mapper using the same process. Now that's just the filtering step of the Schema Mapper in regards to basically reducing the number of features that the incoming source feature would find a match with. So the next step is, if we found that match, we need to now assign those new values or those new attributes. So in this step, it will be a new attribute. Now the new attribute, I'm fairly certain we only use for the asset group type and the asset group and the asset type assignment. So it'd be new attribute. And this is where you'll start to make use of those fields that are the placeholders, basically. So if we'll do asset group first. So the asset group attribute will be the name field. So that's asset group attribute. Right there. And then the attribute value would be your asset group value. It is important to note that the layout of this Excel sheet, I'll just step back into the actual spreadsheet just to see. So while we have them over here, you could move those. You could have them all, you could lay out the spreadsheet as however you would like it, however it makes most sense to you. The only thing with the current workspaces is you would not be able to, if you were to alter any of the names, you would have to fix the workspace for that. But in regards to moving these cells around or the columns around, you could do that as much as you would like. So stepping back, so again, the attribute name is the asset group attribute value here. And then the attribute value will be the actual code here, listed here. And click OK. Now we'll just stop there for a second, and we're just going to run that from here. Click Finish. Just going to move this guy out of the way for a second. Now if we right-click or click this little mapped port here, right-click it and click Connect Inspector. This will basically allow us to run the workspace up till this point, and then it'll open up the inspector with what the data looks like at this point. Now if we click Run, to the source file Geodatabase and the Schema Mapper file here, and click OK. So we had 34 that came out the unmapped. That's not good. So it means one of the steps we performed is incorrect. So if we take a look at the unmapped, so we see water fittings is the Fme feature type. Fitting type is cap and reducing T, so they're all populated. So everything looks good from a first point, but it just didn't map. So if we go back, and we'll take a look at our spreadsheet, and we're using the complete one. So I see water fittings here with a fitting type, I'm just gonna, let's do this here. See if that helps. This is where if you have two screens, this is where having two screens is a lifesaver, because you can have the spreadsheet on one screen and your workspace on the other. So if we take a look at Schema Mapper and go next. So the feature type and the Arcgis feature class. Water fittings. And then primary attribute name, primary attribute value should be fitting type and cap. Secondary attribute name, secondary attribute value. For this one, we don't need one. So, let's remove this filter here. And then we're setting the new asset group attribute and asset group value. So that looks good. So if we finish there, and we'll click yes, we'll click run translation again. And there we go. So we had 34 that were mapped this time. So the step that I just removed was one of our filters. So if I take a look at this one, which was basically an exact copy, if I edit it, the issue that was probably stemming from is this blank attribute value. Is right now we were toggling it as ignore. And I'm just going to double check. This is one of the things that goes back and forth quite often in terms of I thought it was one way, but then it's another way. So yeah, so we need to toggle it so we're not ignoring the blank values. So if we toggle this blank attribute value to don't ignore and click OK. And we're going to go ahead and add that filter that we just removed back in with the change to the blank attribute handling. So we'll add this filter in. And this one is the secondary attribute name for the name field. And the secondary attribute value for the name, or for the value field, sorry. And the blank attribute value will be don't ignore. And click OK. And finish. Now let's try running that. I still don't. Why did it not like that? So for the time being, we'll just remove this one for now, just with the fact that this feature class doesn't actually use the secondary attribute name. Let's remove that and finish. So we'll notice that the 34, again, they came out the mapped port. So if we take a look at that in the inspector, which just popped up, you'll notice you'll see a row ID here. Now for the asset group and asset type, you should only ever have one value here, because this is basically matching the, this is giving you the Excel row from the spreadsheet that a match was found. Now it's always, I believe it's the Excel row plus one. because we do not treat that very first row in the spreadsheet as row number 1, because that's how we read the, those are the column names. Now, so if we select one of these features, like the one I have now, we'll notice that there's no asset group down here, even though that's the value that we had selected to, that's the one where we were creating. However, you will notice you see asset group here. Now, the reason being is just because when a new attribute is created within the schema mapper, it's not exposed. Now, if I just select another one, so that was a tap fitting type. So let's just confirm that with the spreadsheet. So if it was a tap fitting type, it should have an asset group of 20. And there's the asset group of 20. Now we'll do an asset type because we'll notice for the water fittings, they're all asset group 20. So, you know, how do we know that we got it right? Let's do an asset type where we'll start to see the differences between the individual features. So if we go through the spreadsheet or back to the workspace, and go to the schema mapper and click next, we want to add a new attribute. So for this one, the attribute name will be the asset type. So it'll be asset type attribute will be the name field. And the attribute value will be the asset type value. And click OK. And finish. Now we can run that again. So we'll select one of the ones that we were looking at before, which was a tap feature and had the asset group of 20. So here we'll notice that the asset group is still 20, and the asset type is now 55. So we'll see if that does that correlate with the value we were just looking at. So 20 and 55 for a fitting type of tap. Now let's look at reducing T, which should have an asset type of 51. Reducing T here, you'll see the fitting type, asset group of 20, and asset type of 51. So we can now see that the schema mapper is providing us with the correct spreadsheet mapping. So let's go back to the workspace. So now we can add, for again, sanity checking, we could add those 2 additional attributes, the description for the asset group and the description for the asset type. That way we're just not looking at the code, because it provides with a far higher level understanding of the feature that you're dealing with, rather than just trying to deal with the code. So we'll just do new attribute again. We'll be taking a short break in about 5 minutes. So the attribute name field for this one will be the asset group description attribute. And the attribute value will be the asset group description. And then we'll do that one more for the asset type. So again, new attribute. And this one will be the asset type description attribute will be the name field. And the value field will be asset type description. And click OK. And finish. Now, if I don't want to, I'm going to delete that inspector. If I don't want to have to select an individual feature to see if that asset group and asset type mapping was correct, we can just hook up the output of the schema mapper to an attribute exposer. And we're just exposing the 4 attributes that we selected. So if you just hook up the schema mapper to that attribute exposer on your canvas, and from the output of that, we're just going to right-click the little output port and click Connect Inspector. And run translation. So here we'll notice, if I scroll over to the right, we have the asset type, the asset group description, and the asset type description in the table view. That way I can look through this rather than selecting in each individual feature to determine if they are if the mapping was in fact correct. Because you have to remember that it could come out the mapped port, but it could be the wrong mapping. So it looks like those all came out correctly. Now this test filter, this is just a step that's used within the workspace, and it's basically to catch whether or not the mapping was indeed correct in terms of if an asset group or an asset type is missing. Just wanted to reiterate, if you do get lost in terms of the exercise, we do have a completed workspace that you could follow along with as well. This is the schema mapper is by far the most complex part of the simple migration, and can take quite a bit to get used to in terms of how it interacts with itself and whatnot. So bear in mind, if you're able to understand the schema mapper, it is the driving force behind the simple workspaces, and it is by far the most complex part of it. So continuing on, we're going to take a look at the domain mapping for the schema mapper. So if we select this mapped port of the test filter 7 and start typing schema mapper again. Before we get into the schema mapper, I just want to reiterate about this test filter. So again, this test filter is basically just a QA check for ourselves. And it's basically just looking to see if the asset group is missing or the asset type is missing. And if it's not, if those two are populated, then everything else can be set through the mapped port. So the schema mapper. So we've added the schema mapper and it's hooked up to the map port. So we'll go ahead and select, open up the schema mapper. The format, we want the Excel. We want to use our Excel sheet. So we start typing Excel and then select it. And then the data set. If we select the water schema mapping complete here, I'll send out this path as well to everyone. There you go. And now again, remember, because we've selected the data set, we need to configure how FME is going to interpret it, that Excel sheet. So again, we're going to select the little parameters button there, and that'll pop up this dialog window. Now in the first schema mapper transformer, we were using the asset types, but now we want to do the domains. So we're going to untoggle asset types, and we're going to toggle domains. Now if I select this, again, you'll notice that the preview here changes. So now this is looking at the domain sheet of our Excel file. Keep everything else there at default. So we can go ahead and click OK. And now we'll click Next. Now this is where we set up the filters and the how we're going to define what domain we're actually going to be mapping in terms of values. So we're going to hit this little plus sign here, and we're going to add a filter. Now the first filter we want is going to be the Arcgis attribute name and the Arcgis code, or the Arcgis attribute name equals the Arcgis code. So the attribute name here will be Arcgis attribute name, and the attribute value will be the Arcgis code. So these are from your source. These two would be from your source Geodatabase. And again, we want the blank attribute value to don't ignore. So one of the filters we can see as an example would be if the material is AC, that would be one filter. Click OK. And then we could set up a second filter if we had one. So if we take a look at our spreadsheet and we go to the domains, we want water fittings. So I don't have any here, it looks like, taking a look here, that are listed as a feature class specific domain or a possible subtype that I want to map to a domain. So it looks like we might not need to use a filter for the Arcgis feature class or the Fme feature type. Just taking a look. Yeah, it doesn't look like it. And I don't see any values for the secondary attribute name and the secondary attribute value. So it looks like maybe we don't need a filter for that one either. So it looks like we might be able to just do a straight mapping now in terms of setting that new attribute. So if we go back to our workspace, so we have our one filter. So it looks like this filter might be sufficient to set our new domain value. So if we go to hit the little drop down here and new attribute, we're going to set it as the attribute name will be the UN attribute name. So again, this will be the target name that we want to write to. And then the attribute value will be the UN code. And click OK. And finish. Now we're going to run this as is, but we will step back through and review what we just did with this Schema Mapper. So we'll hook up the Schema Mapper to the mapped as well as to the unmapped. The reason being that you want both is because you could very easily have a feature class that did not participate in any existing domains or subtypes or anything like that. So we'll notice that they all came through the unmapped port. Now, if we take a look at this feature here, and I'm going to pull up the spreadsheet, and I should be able to just do this here. Pull that back. Nope, that's the wrong one. Sorry. Data inspector. And then here we go. So here I can see the feature that did not get mapped, and then my domain mapping spreadsheet. So I can look through here to see if any of the filters should have worked. So I see I have a material. Does the source have a material? Doesn't look like it. Does it have a life cycle status? Doesn't look like it. And I could continue doing this for each of the ones that should have found a match. which would only be, in this case, life cycle status and material. So this is why it is important when doing the domain mapping that you that the output port should be toggled. The output ports for the domain schema mapping should be both proceeding through the workspace, because in this case, I didn't have a single domain that was mapped. Now, just to step back into that schema mapper just one more time, just to review. So we selected our Excel sheet. We toggle how that sheet is going to be read. In this case, we only wanted the domains sheet. And then in this case, we only had one filter. If I edit it just to review, with the Arcgis attribute name being the name field and the code being the value field, and then not ignoring the blank values. We are then able to set the new attribute with it being the UN attribute name as the name of the field, and then the UN code being the value of that new field. So you will notice when you look, if you look at the completed, the full in-depth water workspace, that you will have additional filters here. And that's because, so if we were to have, taking a look at our spreadsheet here, if we were to have system valve, for example, go through this schema mapper with the water fittings, we would have to set an additional filter here. And for example, this one, if we were to send it for the system valve, it would be, we would need the attribute name field would be the feature type attribute, and the value would be the Arcgis feature class. And again, that feature type attribute in the spreadsheet would always have a value of that FME underscore feature underscore type. And then the Arcgis feature class would be the name of the source feature class. In this case, system valve. So if I had clicked OK, if I had set the filter there for that one, the system valve would find a map. And then just to look at the last step of the schema mapping, which is the attribute value or the attribute name mapping. So if we add a schema mapper to the unmapped port, just want to review something here. I may have made a mistake here. Nope, that's okay. Okay, so open up this schema mapper 3. We can do the same steps. So Excel file. Target the Excel file. And then parameters. Uncheck domains. Now, because this one is the attribute mapping, this is where we use those the target feature class specific sheets. So in this case, I believe if we take a look at the asset type sheet, water fittings are a water junction. So if we go back to the workspace, we want the water junction sheet. And you'll notice again, this sheet is a lot smaller in terms of we only have 3 columns to work with. So we click OK, and then we click Next. And this one basically should only have one action to take place, and that will be an attribute map. So the source attribute field will be the ArcGIS field ArcGIS feature attribute, which will correspond to the ArcGIS field on the source feature. And the destination attribute field will be the UN attribute name. So source is the ArcGIS, and UN will be the destination or the target. Here, this is where you could set the UN attribute default value if you'd like. We'll set it for now. And then the source attribute we want to remove. And click OK. And that is it for the attribute mapping. So now that's hooked up to the an inspector. Just going to delete this extra one here. So if we run this, we should get features out of the mapped port here for the Schema Mapper, which will be for this attribute name mapping. Click OK. Just want to make sure that come out of. So they came out the mapped port. And then let's get a feature that we know should have been mapped. Let's do location description. So we should have a lock disk. And there it is there. Oh, looking at the wrong table. Here we go. There it is there. So you notice I have some lowercase ones. Anything that's lowercase is the feature that is the result of the attribute mapping from the Schema Mapper. And you'll see the schema row gave me a match. Let's go back into the workspace here. So that's it for the schema mapping. So I'm just going to review, I think, in my opinion, the most advanced one, which is the asset group type and mapping. And if you recall where we ran into the issue with the nulls, with that additional filter, it's in the Excel parameters. If you toggle down advanced, I believe it is. Yes, here we go. You'll see this read blank cells as parameter. So this you'd want to be want it toggled as a null. And you'd want this parameter set for each schema mapper. It is set by default. It should be set in the completed workspaces that you can work with. But for this example here, we'd want to set this as null. So if we go OK, and then if we go next, we're going to add in that secondary filter that we were having issues with earlier. So if we insert row, filter, this one will be secondary attribute name as the name field, and secondary attribute of value as the value field, and we want to ignore. And click OK. And finish. Now I'm just going to disconnect this test filter here, because we just want to see the results from the schema mapping with that additional filter, which was showing up as unmapped before. And they all came out the map port that time. And we'll see the asset group along with the descriptions. Same with the asset type and description. So we can go ahead and save that if you'd like. We're going to step into another exercise now. I think this is the one here. Actually, we're going to step back to this one after our following break. Let's take a look at the conditional junctions. So the start is here. I'll send out the path to everyone. Oh. Oh. Sorry about that. Don't know where that went. There we go. So here we have a fairly blank workspace. Because one of these steps in the simple migrations is having to set to create basically conditional junctions, basically having to create a new junction feature where two lines, or at possible T junctions, for example, where you may not have currently modeled your data that way, because in the new UN you will have to model with the junctions between features, such as where a water main connects to a water lateral. So the first thing we'll have to do in this workspace is we need to add the reader, which will bring in our feature classes. So if we start typing on the canvas, file Geodatabase, we'll see this one here, this Esri Geodatabase file GeoDB, or the short name geodatabase_file. And we want the reader. So we go ahead and click that. This will pop up our reader dialog. So if we hit the little ellipse here, we can open the folder browser. And you'll notice it has defaulted to the folder that we were just in. We want to go back to the new junctions. And this will open the new junctions folder. Can I copy from here? No. And we want the training water _ junctions GeoDB. I'll send this path out through the chat, just in case you're having issues finding it. There it is. Now, parameters, for the most part, we can leave the defaults. However, the table list is required, because that way it'll allow us to select which tables we want to read. In this case, we're going to do water fittings, water services, water mains, and water laterals. And we'll do water hydrants. Why not? So everything but the service territory. And click OK. And actually, when you're adding a new reader, you can there is this little section down here called Schema Attributes. So if we select this and toggle this Fme feature type, this will expose this Fme feature type on each of the feature classes we're adding. It saves a little bit of time when you're adding, if you're adding your feature classes all at once. And we'll click OK. Otherwise, if you wanted to add to expose that Fme feature type attribute, you would have to do that through the Format Attributes tab for each. So the water fittings, we're going to put over in the fittings little bookmark here, as well as the water hydrants. Hydrants might not, technically be a fitting, but they are a point similar to the fittings. And then the water laterals, mains, and services, we're going to drag them down here to our lines. Now for the fittings, we're going to hook them up to this bulk attribute renamer. And the lines, we're going to hook up to the generalizer here. Something like that. Now you notice there were a couple of red cogs or gears, and that was because a transformer was incomplete or missing a required parameter. Now, because this workspace was basically pre-configured, all we had to do was hook up the readers. It will use the existing transformer settings that had been set up that may have just been missing, in most cases, an attribute name. So we're just going to step through this process of how we create those conditional junctions and an example of why we create them. So here's our source data set. Please forgive my colorization. So you'll note basically the junctions that we're going to be creating are where a lateral connects to a main. So an example would be right here. So you'll notice I don't have any point feature here. I just have two lines connecting that will be different asset groups and thus require a junction feature. If I just move out. However, I don't want to create a new junction for a feature that already exists. For example, I could be creating a junction. I could possibly create a junction there, but I don't want to because my source data already supports that. And I can't have two point features on top of one another in the UN. If we go back to our workspace, so we do a little bit of cleanup with the lines, and that's just a generalizer, and that's basically just to clean up some of the data and reduce the frequency of points or vertices rather on the line features. Bulk attribute renamer, forcing everything uppercase. Attribute value mapper. Now this one's a tricky one. In regards to, this is not necessarily required depending on how your diameter field is set up. If it's set up as a straight one-to-one in terms of regards to a one source value equals a one in the destination, it isn't necessarily required. It's only required for the unknown, because depending on how you set your logic for the type of junction that we will be creating, and I will go more in depth with that a little later in the workspace. It is just important to note that if your domains are not one-to-ones, it's recommended to do that just for this lookup table. It will not alter your destination diameters at all. It's just used for the type of feature we will be creating. Now, somebody just noted services is a point feature. So yes, it does not make sense for this point feature to be down here. So we will drag this guy back up to water fittings. Now the attribute keeper here, continuing on from the attribute value mapper, is just basically doing some attribute cleanup. Basically just allowing us to determine which attributes do I actually want to keep for the time being, because attributes can get quite unruly very quickly. Attribute creator, basically I'm just creating a dummy attribute that will contain the original feature class name, because this Fme feature type does change throughout a translation. So it is important that if you do require that Fme feature type from a specific time in the translation, just map it to a new attribute, just so you can, track that feature. Now, coming from the fittings, we go to the bulk attribute renamer, which is, again, forcing everything uppercase, and then into an attribute creator. Now, this attribute creator is basically just setting a flag for us to monitor, and it's that these features already exist. Now, those lines and the fittings to this point both go into the topology builder. I believe Ryan talked about this yesterday. Basically, what this will do is it will node all lines for us. So essentially, it will create those new junctions out of thin air, and then it's just up to us to decide which junctions do we want to keep. So the one thing about the topology builder is it can create a list that's it does not allow you to create a list with specific features, but it does create a list with every single attribute that was on the designated feature or the connecting feature. So that's why it's helpful to use the attribute keeper to basically remove some of those attributes that you don't need. So while I'm using a keeper here, you could use an attribute remover if you would prefer it that way. So we then use an attribute remover here, and we're just removing some lists that we're not going to require. Now this is kind of where it gets tricky. So we send those nodes that have been created out of thin air into an anchored snapper. We then send the lines before the topology builder as the anchor in the anchored snapper. The reason being is we want to ensure that those points that we just created are snapped to the line. We then send from the anchored snapper, from the snapped and untouched, because it will report as untouched if it was already on the line and did not require any snapping. We will send both of those into the point port of the point online overlayer. We then again send the lines pre-topology builder into the point online overlayer. Now here is basically we're trying to create a new a list ourselves with the desired features we want, desired attributes. So in this case, I'm selecting all the attributes from the designated feature. Now, it is important to note that this is a list on the output point. So basically, this is the line features that will be generated on the point feature. Just close that. Now we send the output of the point online overlayer to the test filter. Now this is where we start to essentially throw away some of those junctions that were created based on the criteria we've selected. So if we open up this test filter, we'll see basically we have two tests. We have one testing if it's an existing junction, and that's based on if the exist flag was populated with the exists, and if the list on the line feature class on the point list is missing. If it is missing, that's classified as existing junction because we've not populated that. Or the second test is if the exist flag is missing, so we right away we already know that it is a new feature or a new junction, and the source feature class on the line from the lines that are connected to it has a value. It is a new feature class or a new junction. The rest we don't care about if they don't match either of these two. So we send the new junctions into a Python caller. Now the reason it requires a little bit of Python here is because in our list searcher, we're not able to search more than once. And we're not able to search at the exact same time two different values. So we basically do a little bit of Python that essentially will search for two values. So I'm just going to step back a bit and notice a few questions coming in. So the node angle source feature class, I'll step back to the very beginning here. The attribute creator 24. So that's on the lines. So that's where we're basically just mapping the source feature class name, so water laterals or water mains, to this source FC. In the topology builder, it will create a list of every single attribute that's on it. But we do not want the list that is generated from the topology builder. We basically are just using the topology builder to create those new junctions for us. So that's why we remove the list here in this attribute remover. And then we create the new list with the features we want. Using the point online overlayer. So this is where this node angle, so here's the list name, which is that node angle, and the attributes that will be on that list. So this is where that node angle dot source FC is created for the one that we want. Because we use that node angle source feature class in the Python to basically match it with the name of the feature classes. We then store, using a list searcher, the source feature class. We search for the laterals, basically because what we want to do is we want to find out if the lateral feature class does exist on one of the lines. And we store that in an index for later use. We then count the elements, basically just counting the number of lines that are connected to that point. And we'll copy the attributes from the index that matched the water laterals feature class. And then this test filter, this is where you then basically the features that make it this far will be the ones that you want to create, or will be the ones that are created, the features that make it this far will be the ones that are new features, new junctions, that you will then have to pass in to your schema mapping. So depending on the logic you are using, now this is set up for the Naperville sample data set. So this is where you basically would perform some test conditions on how your features are going to be categorized. So for example, so after these coming out from these T and tap features, I would have an attribute creator that would basically create some dummy mapping to allow them to be joined with the actual Schema Mapper transformer. So we can see that in the fully completed workspace after the next break. But let's go ahead and give this a run. So you'll notice it asks for a couple of inputs here. Now, the name of the source laterals feature class, this will be, in this case, water laterals, but this would be tied to your the name of your water lateral feature class. Same with the water mains. So if we could go ahead and click OK. Memory serves me right. I believe we should get 4. I think we call them, I think they're taps in this one. That pops up there. So I'm just going to minimize that. So we'll notice we got 4. I'm just going to fix my connections. The curved, I like the squared better. I find it easier to follow. Here we go. So we'll notice we have 88 new nodes were created. Now, if I want to see the output of this topology builder, say I want to see it with the lines, I'm just going to right click it and inspect cached features. Because remember, I do have the feature caching toggled on. So here I can see all the lines as well as all the nodes that were created. So if I minimize this and go back, so I'll notice that my fittings, that's not what I wanted. I have 30 water fittings, 5 hydrants, and 20 services. But I somehow created 88 new nodes. So this is where it begins that we need to start to filter out those 88 features, because those 88 features will not be, I don't want all those 88 features. And then in this test filter 2, we're starting to whittle down the new junctions, because if I take a look at these, and if I overlaid the, actually, let me close that for a second. So if I want to see just a quick tip, if I want to see two flows of data through the workspace, if I have feature caching turned on, I can select either the output port or the line of the features from 2 different workflows. So I'm going to select the new junctions here, as well as the lines here. If I then right click and click the inspect cached features, it should bring up both. So here I can see all 33 new junctions that are being, or new junctions that are being flagged as new on top of my lines. Now, some of these I know will not be a new junction. So if I select this one, for example, so the line first is a water lateral, and the line it's connected to is also a water lateral. So right away, I know that that's not a junction that I'm interested in modeling. So it's one that it was created. It kind of matched the criteria that we selected in regards to the exist flag was not populated. And the source feature class had a value in regards to a line was connected to it. So the Python is basically just testing whether or not we have both feature classes from the lines. So basically it's testing if the lines that are connected to that point, if they're a water main and a water lateral. If they're all just water laterals, and we'll take a look at that just to show it. I just select one of these. So I know, I think this one up here was the one. So here we go here. So if we look at the list here, I'll notice that the feature type, or the source feature class, which is what I'm using, is water laterals and water laterals. For our Python, that doesn't meet our criteria of the junction we want to create. The junction we want to create needs to be have both line feature classes in it. So it needs to have a water laterals and a water mains. I think there's one down here. Yeah, here's one that we know. So we'll see one of the first element, or the first line connected to the point, is a water main, and the second line connected to the point is a water lateral. So that would meet our criteria of being a type of junction we want to create. And then the test filter 11 is probably the most important part, because that's where you will start to set the type of test to determine the type of feature. So you'll notice I only had 4 come out, but I had 29 go in. So 25 didn't meet. Now if I select this one, let's see the best way to do this. Yeah, so I'll select this one, and I'll select this one. So this will give me all the existing junctions, all my existing lines, as well as my new junctions. I'm just going to do some very, very elementary symbolization here. So those are my existing source junctions. Just going to set these as those are my existing lines. Now here's my new junctions that were created. I'm just going to set them as black. And I'll bring those up so they're the top. So I'll notice 1, 2, 3, and then here's the 4th one. And if I check the lines that were connected to it, I see water lateral, water main, same thing here, water lateral, water main. So those are the new junctions that we created that we would then join up with the remaining workflow to get schema mapped and to proceed through the workspace as if they existed in your source from the beginning. As Mark just chatted out, the section that we just reviewed, the conditional junctions, this is for those data sets where if you do not currently map those, in this case, T's at all. For example, in the sample data set that we had worked with, they did not. As such, we had to create them. So if you currently do model them, you would just treat them like any other feature class in regards to the schema mapping, and you would bypass this topology builder section in the completed workspace. Now we are going to step actually into the completed workspace now. So we can go ahead and close this one. I'll chat out the path for this one. We're just going to step through this, step through the some of the areas that I did not quite touch on yet that might change depending on your source data set and whatnot, such as associations for simple migrations and whatnot, and that type of additional functionality that is required when going to the new UN. So here's the completed water migration. We've tried to lay it out in regards to each destination feature class, because we do try to get, with using the schema mapper, we try to get into the asset package and utility network data model right away in regards to the schema, which is why we do the asset groups and asset types so quickly in the workspace and so early. So for each of these workflows, which we've tried to label as, they're, like I said earlier, their structure junction or their structure boundary, water junction, basically the destination workflow or target that you will be writing them out to. That way you can kind of try to follow the workflow as such, because it is, aside from like the special cases or the little nuances with your data set, it's a fairly straightforward and repetitive task in regards to the schema mapping aspect of it. There are certain little special cases that have to be accounted for depending on your source data set. Some of those special cases that we have implemented, for example, one of them was the conditional junctions, which we just talked about, was one of the special cases. Another one that we did see was if your pump stations were a point in the target asset package in the utility network, pump stations need to be a polygon or a boundary, and the pumps would be represented as a point contained within those. So, so you can, like I said, account for special cases depending on your particular data set that you're working with, and just account for them accordingly, depending on how or the type of change you will be required to make. One thing that you will most likely have to make changes to is the associations. Now, if you are, if you have some background with the utility network, you know this concept of associations that was introduced. They differ quite differently from the basic migrations that Mark will talk about tomorrow. But there are certain ones we do have to create for the simple migrations. Now, the simple does not have the concept of a true assembly or a high fidelity assembly device where you model each individual device within it. But there are certain cases that you do need to still create an association. One of them I just mentioned was the pump station and pumps. So if you have pump stations and pumps, they need to be associated with one another and be written out to an additional table that is referred to as the C associations. We have not talked about this table yet, but it is primarily used just for writing out an association. So that could be two junctions, a structural attachment, or a containment. For the most part, the simple migration, it'll be a containment in most cases. This could be a pipe contained within a casing. This could be a pump contained within a pump station, and so forth. The C associations table, rather than writing the asset group type and asset group values, you write the descriptions. So this is why when we do the schema mapping at the beginning with the attributes, with the attribute assignment for the asset group and asset type, that we also bring in the descriptions. This prevents you from having to do a lookup later on before writing. Now, conversely, this is also where we do a terminal assignment configuration lookup. This is referencing, just maximize that. This is referencing this sheet here that I mentioned. And basically how it works is it looks to find a match with the asset group and asset type of the given feature. And if it does, it will assign the terminal that will then be written to that associations table. In the sample data set that Esri provides, there were no terminal lookups that were found. It's still included as an example, but no results will be produced with the terminal. The pumps for the containment associations, they can differ in how you create them. We created a couple. So for example, we have pump stations and their pumps, the casings and their pipes that are within them. But depending on your data set, you may have to add additional ones, and the pattern might be the same, or you might have to create a new workflow to handle them. I think, for example, if you run the sample data set, I think it's something like 19 associations are created. As an example, another thing that we haven't talked about yet is the QA. I've briefly mentioned it in a couple, like doing some test filters where we check to see if an attribute is missing, such as like the asset group and the asset type. We try to flag any either schema mapping errors and write them out to a redline geodatabase. That way you can actually see the geometry of the feature as well as the attributes. You can customize the reporting to showcase any attributes that you deem valuable in regards to the schema mapping. So I would personally recommend for any of the schema mapping you're doing, make sure that you write out to the redline geodatabase any of the filter attributes that you are using. That way you can determine, okay, well, why didn't this feature get mapped, or why was this mapped this way and not this way? Because that is one of the biggest headaches of the simple migration, is trying to get that schema mapping right. We also do flag, so for those users that might have to create those new junctions, we also do flag them as a new junction feature. That way you could write those solely new junctions that were created out to the redline geodatabase for QA QC, just to ensure that those are created the way that you would like them to be. Now we do also write out to an Excel file as well, the errors that are found. In most cases for the simple, it will be related to the schema mapping. In most cases, it will be tied to the asset group and asset type assignments. That seems to be where the biggest issue generally stems from. And just for clarity, that will be the first schema mapper you encounter in each section. We've tried to, within the bookmarks, we've tried to label as what each little section is doing. For example, the green is the asset group and asset type mappings. The tan color is the domains. And then the dark blue here, or the violet, is the structure or the attribute mapping. Green or the light green rather, is any type of attribute or validation check that you would like to perform. Big one that we encountered when working with the sample data set was install or any date fields, ensuring that they were in the correct format. Because basically, so in that schema mapping exercise we did, where we kind of stepped through the asset group and asset type assignment, as well as the domain and attribute mapping, this is basically where the workflow stopped. So where we continue in the completed workspace is any type of attribute check that you would like to perform. This could be assigning a default value if you'd like. It could be checking like I said, the date field format to ensure that it will be written correctly. And then we have the null attribute mapper, which it can be used if you performed any of those dummy nulls at the beginning of the workspace to make use of the asset group and asset type assignments. You could map those back to a true null if you so wish, rather than using the dummy null value. And it basically works as the opposite in regards to it. It looks for that dummy null value, and if it finds it for the designated attribute, it will map it to a true null. So you could select whichever attributes that you had selected at the beginning in that null attribute mapper. So for water fittings, I think we did fitting type and global ID. You would select those here. And then the bulk attribute renamer, this is just allows you to determine the case that you want to write out to. Now, I believe currently the asset packages default to lowercase. But if you were to make changes or to create your own asset package, for example, you could match out accordingly. You could match your case type to that accordingly, because again, FME is case sensitive. Now, from a very high level view, we've kind of included some steps here as to kind of the workflow that might have to occur depending on your data set. So the first one would be you would import your new feature types. And to do that, we recommend adding a new Geodatabase reader rather than altering the one that is currently within the workspace. The reason being is you can add a new reader. So for example, if I go add reader, so file geodatabase, file geodb, going to specify the file geodatabase. So I'm just going to select this junctions, select parameters, the table list. I'm just going to select water mains and water laterals just for an example. Oh, and here again, we would schema attributes, additional attributes to expose, FME feature type, and click OK. And OK again. Now, the reason we recommend adding a second file geodatabase reader for your data set is because this will allow you to add all your feature classes and connect them and basically match them with the existing sample feature classes. So I have two line features here. So I can see, water laterals probably is similar to W lateral line. So I can match that up there. And then water mains is probably similar to W main. So it just provides you with a greater greater idea of how your feature classes should be aligned to the workspace based on the sample data set. Once you've added all your feature classes, you can either completely disable the sample geodatabase reader. To do that, you can just select it and then disable, and it will gray out all the feature classes that are associated with that specific geodatabase or that specific reader, and you would still have yours present and enabled. When doing this, while you can bring in all your feature classes at the same time, it would be recommended not to run the workspace for the very first time with your spreadsheet completed all at once. Either try to run it, feature class by feature class, or maybe like a feeder by feeder, something like that. That way, you reduce the level of QA that you have to check, because if something's going to error on the very first feature class, you don't want to have to set all the configuration up for all 12 feature classes, for example, or more. When it's it could be quite a simple error that you where just it could be a typo or a case change. A couple problem areas just to highlight that are probably where you may run into issues, or would most likely be the spots that you might run into issues, is one, the schema mapper. It can be quite confusing. I still get confused by it. And the best way to do that is to troubleshoot it is just one, if you have two screens, that's by far the best, because you can have the spreadsheet up on one screen and the schema mapper parameters or data inspector up on your other screen to compare the differences. Another thing is, so don't run, kind of going back to how or what's the recommended approach in terms of running these workspaces. If you're doing it feature class by feature class, if you have a feature class that is enormous and you're getting into the issue where you're spending more time running it than actually debugging it, but you're still or you're spending more time waiting for it to run while you're trying to debug, you can add some testers in here. So for a water main, say I'm testing, say I'm working with water mains right now. So if I just select the water mains feature class and start typing tester, it will allow me to, basically I can filter out the type of features. So say I'm having issues with, let's look at our spreadsheet. Say I'm having issues with the distribution main and the null, the dummy null that we're creating. If I set a tester for only selecting if the fitting type was null or the diameter was null or the material was null, I can then reduce the number of features that I'm running the workspace with. And with using the feature caching on, it allows me to speed up my debugging process, because if chances are, if I have 100,000 fitting null material fitting types or null material water mains, if I can fix it for one, if it's the same problem across those 100,000 features, running it with one feature, fixing the issue, and then running with all 100,000 should carry over. If it doesn't, it means that those two issues are originally with the two offending features were not the same. So trying to limit the number of features that you are running with at the start can be quite beneficial to the success, to your chance of success in regards to producing your desired and expected and successful output. Now you don't have to. So when we write out to the asset package or the file geodatabase, we are basically creating a copy of the original asset package. So if you have made changes to your asset package, you would have to change this template file geodatabase parameter here. Now, just as an example, this is also prompted when you click run. I'm just going to delete this tester. And then, so if I click run, I'm not going to run this whole thing, but you'll notice quite a number of parameters that you get prompted for. So I'll just go through them from the top down. So the target asset package is basically what you are writing to. This will be the location of the geodatabase that you are writing to. You want to ensure that this actually isn't the template you're writing to. This will make use of the template, but is not the template, if that makes sense. It's a little confusing and can be a little tricky to understand. But you just want to ensure that either the name is different or the path is different if you're going to try to use a similar name to the asset package. The data errors Excel file. This is just one of the QA files that we write out to if there's any errors. In this case, it's generally the asset group and the asset type mapping that are written out here. The Schema Mapper Excel file. Now this is the Schema Mapper Excel file that I mentioned that we took a look at. However, we've set it up as a parameter, whereas in the Workspace examples we looked through, we had it set up just hard-coded. So in most cases, if you change it here, it will riffle through the Workspace to each Schema Mapper. Now there are, I believe, 2 Schema Mappers that are asterisked, so to speak, and they try to alert you that they, due to a bug in the version of FME that these were developed with, require to be hard-coded. Now the asset package template geodatabase, this is the template that you will be making use of. So if you had made any changes to the asset package, this is the one that you would be making that would be used as your template. So this contains the definitions for all the asset group and the asset type. Now it is important to note that any of the feature classes you are writing to, such as the domain specific ones like water junction and water device, and the structure domain, those need to be empty, as well as the C associations table. Otherwise, those features will be included in the template. So ensure that you are using an empty asset package for the template. The name of the source laterals feature class and the name of the water mains feature class is only used if you are creating those conditional junctions. And these will be the names of your lateral feature class and your water main feature class. The case is the output that you are going to write to. Again, I believe the default is lowercase for the asset package. However, if you've made changes or created your own, you can choose the case that you would like. The source file geodatabase is your source geodatabase that you would be reading from and migrating from. The red line geodatabase is the red line geodatabase that we write to for either QA checks for features that did not make it through the translation to the writer, or for those new junctions that you can monitor as well. And then this last one here is the reader I just added. So normally it would not be there. So if you do make changes to to the asset package that you will be writing, that you are using as the template. If you have added attributes, anything like that, before you, sorry, I'm gonna step back just to reiterate, I lost my track of thought. So if you've made any changes to the asset package that you will be using as your template, such as attribute names, if you've added domain definitions, anything like that, you cannot use these default. You would not want to use these default feature classes for the writer. You would need to update them to yours. And the process to do that would be to go to writers, update feature types. You would select your writer. In this case, I want the water staging database. Click OK. Basically, you'd want to select the writer that matches your asset package writer. So here I will select the feature types I want to update and how and where I want to get them from. Now, this is my water staging database. So this is my output, but this is not where I want to derive those feature classes or those changes from. I would want to derive them from the asset package. So I would select the data set. I'm going to hit back and go to complete. And then right away, we'll see the water distribution, name's kind of squished here, asset package empty. So this is the one that I would want to get my updated feature classes from. So if I select OK, or select it and then select .gdb and then go to parameters, it's important to note that we're not going to be reading any data from this. We just want the schema definition for those feature classes. So if I select the table list, I can then select whichever tables I have made changes to. For the most part, it probably will not be the C associations or the service territory, but the domain-specific ones like structures or water would be the ones that you would want to bring in. So if I click OK, and then OK again, and OK one more time, it shouldn't break any connections here. So it'll ask me the feature types, and these are the ones that are matched already in my workspace. So these were already existing. Click OK. And then it merges them together. So the only way that you would be able to tell that this is successful is if you looked at the original. Say I had added an attribute of date ID, for example. It would then be available for viewing down here. Along with any other changes that you had made. So it is important. That is a step that, for the most part, I imagine most people would have to perform this step because there will be, I would think there will be changes that you are going to make to the default asset package to better suit your desired needs. Now another thing to note is the workspaces, the source data, the source data set that you are working with, because the migration process to these asset packages and conversely to the UN is essentially on a case-by-case basis because no two data sets are the same. The more comfortable you are with your source data set, especially in regards to the cleanliness of it, because if you know that there's going to be issues that you're going to run into, it is better to try to catch those ahead of time, or you could institute them into the workspace if you are comfortable enough. And those could just be included in those special cases that I had mentioned earlier, like the pump station boundaries or the casing. One of the data sets that we dealt with was the casing was a polygon feature, whereas in the asset package, it's written as a line feature class. So little things like that, the little nuances that you'll pick up, the better you understand the target and your source. Now, I'm just going to take a quick pause for a second, and just by a show of hands, we'll do a little bit of a pause in between each one. If you're interested in water, can you raise your hand? Like the water workspace or the water migration, can you raise your hand? Okay, yeah, quite a number of you. Now I'm going to lower everyone's hands. Now, if you're interested in gas, the gas migration, can you raise your hand? And then lastly, going to lower everyone's hands again. If you're interested in the electric migration. Okay, thank you. Now, just to kind of review what we've covered so far. So the Schema Mapper, which actually we do have we have another exercise that we can do with the Schema Mapper, because I think that's going to be the largest problem spot, I think. So we're just going to pull this up, and I'll send the link to everyone. So I chatted out the workspace link to everyone. And if you go ahead and open the incomplete water schema mapper, I'll send out this. I'll chat this out as well. So we'll start in the spreadsheet first. I'll close this one. Oh, I might have already completed this one. Actually, we'll do the error ones instead. Apologies about that. So there's the error spreadsheet path. So we'll see if this is the right one. Yes, it is. Okay. So looking at the spreadsheet with also the water schema mapper errors workspace, which I think I'll send that out. Scroll over to the filters. So I'm just going to, we're going to disable the writer because we're not going to write out the output. So if I select the water staging database up top in the navigator pane, if I right click that, I can click disable. Just going to turn off this parameter editor window. There we go. Now if I scroll back over, we're going to do fittings for now. And then I believe, so if I click run, and we're using the errors one already, so this should error out. If this works, I will alter it so we can see the errors. Oh, I forgot to disable the asset package errors. Yeah, so that one worked. So we're just going to go in here for the water fittings just to show the case sensitivity that Fme experiences, because this is in most of the issues I have seen raised from the schema mapping is generally a case issue in most. So if we go fitting type for water fittings, and we're going to just save that. Oh, cancel. Hoping this won't break it. Haven't used OpenOffice very often. Never mind about that. So basically, what I was trying to showcase is if you change all your, if you were to change the attribute names to lowercase, Fme will still not find a match because of the case sensitivity And because you don't get an option with the toggle unless you were to manually do it in regards to the bulk attribute renamers. So we force everything to uppercase, but we don't give you an option to change this. So if a user, if you were to come through and change, especially the fields that are shown and commented as being case sensitive, if you were to not ensure the case is matching, match any type of mapping, whether it's the schema, the domain, the attribute mapping will not match. That's pretty much all I had to cover today. If anyone has any questions, we can I'll review them out loud, or if anybody would like anything reviewed, I can definitely review the schema mapping if anybody would like some additional coverage on that. I know that is quite difficult to wrap your head around. And in case you're going to step out now, just a reminder, so tomorrow we will be doing a deep dive into the electric migration, and which is also the first chance we'll have to take a look at the basic migration process for the basic level of utility network support. So if you're interested in electric, please come back tomorrow morning. So I have one question that came in. So how did we generate the schema mapping? So we generated it for the most part in terms of, so I'm gonna I'll show the entire, I'll unhide everything so you can see the entire. So we generated, so it's basically this current one. It's lists the default asset group and asset type combinations in the default asset package. Now, as you can see, for the most part, a lot of these fields are blank. Now, that's just because the data set that we worked with for creating the migration was that there was no, the data didn't support it. Now, we also, if you were to add any asset groups and asset types, you would have to add them into this spreadsheet. You could probably create a automated way to do that, to create the bulk, or at least the definitions. But for the most part, for the anywhere that is user by user data set dependent, we filled it out essentially by hand. So using the Arcgis feature class, so populating these, these fields, and then copying and pasting these ones over here, because these ones just repeat. So just to go over the schema mapper, I have a couple of questions coming in about that. So the first part is the reader. Now, it is important to note, if you make any changes to the only way to populate the, so for example, if you were to change any of the field names, or the column names rather, in the Excel sheet, if you were to change any of those, you would have to re-hard code the schema mapper before changing it back to a user parameter, because when I make it a user parameter, just to show in the completed, that's the wrong one. So if I go to the Schema Mapper here, which is a parameter, if I go to parameters here, you'll notice I don't see anything. Now the reason being is because it assumes that the schema of that Excel sheet is going to be the exact same as it was before you converted it to a published parameter. So if I were to come in here and change this to the complete, you'll notice I get a little exclamation mark. It will then show me everything that it's reading again. So if I change this to asset types like we were, read blank cells as null, okay, so click OK. These are all populated, so that's fine, and click finish. So I could then come back in here now and change this to a published parameter. Now to do that, you have to do it by hand in the build that this was created with, and that would be, I think it's Schema Mapper Master, and there you go. You'll still have to click next to populate it, but everything else should stay the same. So if you are changing the layout of the Schema Mapper at any point, you will have to hard code the Schema Mappers and then change them back. And then for the actual filters and whatnot, it helps to do it in little increments. So set up a filter for just the feature type in Arcgis feature class if you have any features that are mapped just based on the feature class. Then add another one and so forth. So it helps to do it in increments. That way you can you're debugging one at a time rather than trying to debug all four. Okay, is it the primary attribute that wrong? Is it the secondary? Is it the tertiary? And one thing to note that I have seen a few times is if you change the names of these at all, these values, this can provide an issue because we are looking for especially the asset type and asset group along with their description, we are looking for these specific attribute names in the Schema Mapper. So if these don't exist, it can cause issues. So ensure that if you're doing a mapping, that these are populated. Otherwise, if they're not populated, so if I were to delete these out, nothing would be mapped because no filter would be found or anything like that. Seeing if there's any other questions coming in. So that's it for today. I don't see any other questions coming in. So please join us tomorrow morning at the same time, 8 a.m. Pacific, for a deep dive into the basic migration, which will cover the electric.